All right. So we are starting a new topic, and that is called parametric equations. So hey Derek, hi Syed, Arush. So we have Arush, Davik and Syed in the classroom, and we have Vishal, Jenna and Dev online. So we are starting a new topic called parametric equations. Has anybody heard about it? Can you guys do you want to teach your teacher real quick before your teacher gets started? Any view that you guys have? Any guess? Vishal, Dev, Jenna. Give me some point of view, some absurd, weird, relatable, non-relatable, any point of view is okay. No? Jenna, Vishal and Dev, do you guys want to give it a try? No?
Wait, what is it called?
Parametric equations.
Yeah, I have no clue.
No clue? That's good. Okay, so I have my job intact. I can claim that I am teaching you guys something. Okay? Alright. So, now, does anybody know in the class what is a rectangular equation? No? And I have no hesitation in saying that you all know about it. Now, let me give you an example. These are called rectangular equations. All the equations, be it linear equation, be it quadratic equation, or any kind of polynomials that you guys have dealt with, are called rectangular equation. And then you'll say why? Because, yes Dave.
Is it like, are they like shapes like flowers or something? Because I've seen them.
You'll have to be a little louder for me, I can barely hear you. Now I'm saying you'll have to be a little louder for me, I could not hear you well.
I was saying like, I think I might have, like, there's like an equation that's like a different like type of shape, like a flower or like something along those lines.
I love your creativity. But on a serious note, no. There's a different way to look at it. Hey Tanvi. So Tanvi, before you joined, I was bugging everybody to understand if anybody in the class knows what is a parametric equation, because that's what we are trying to learn today. And since I did not get an answer, so I said, okay, do you guys know what is a rectangular equation? And again, the answer I got from you all was no. And I was countering that by saying that no, everybody in the class, including me, knows about what is a rectangular equation. Any and every equation that we have dealt with so far, right from grade 5 till date, those are called rectangular equations. Why? Because you are dealing with two variables, x and y, which you can very well represent in a rectangular plane. Your coordinate plane that you look at it, it is pretty much a rectangular plane. You have one dimension along the y-axis and you have one other dimension on the s-axis. So you have two dimensions. Any rectangle has two dimensions, length and width. That's why these equations help us represent or plot x and y values in a rectangular plane, and that's why they are called rectangular equations. Does that sound okay, or you guys want to counter that? Okay, so all the equations we have dealt with thus far is called a rectangular equation. What we are going to learn about is called parametric equations. Now, again a moment of silence. How is that different from rectangular equation? And why do we even have to bother about a new thing which may or may not be adding value. So let me kind of decode this little bit for you guys. Can everybody hear me okay? Vishal, Tanvi, Dev, Jina, you guys anyways can hear me okay? Okay. So here if you look at this equation or this equation, our observation is that the value of y is dependent on x, or value of x is dependent on value of y. Fair? Look at this equation. Here, what will be the value of y will be determined by what is the value of x, or vice versa. Agreeable? Everybody? Now, let me add some color to it. I am saying that x and y here in this kind of equation, rectangular equations, x and y are related to each other. Meaning x is dependent on y or y is dependent on x. Or the value of x is dependent on y, value of y, or vice versa. But what if x is dependent on t? Let's say t is something, be it angle, be it time, be it whatever, any third thing, not x or y. And y is also dependent on, let me give it a different name. So here, if you look at it, x is a function of t, and y is also a function of t, with different contract, different agreement. Let's say, I'm just making it up. Let's say x is dependent on t, where x is equal to 20 plus 3t, and y is also dependent on t, where y is equal to, let's say, 20 plus y20. y20. So the simple interpretation by looking at this and this set of equation and this set of equation, simple interpretation we have is, here in this case, value of x is dependent on y or vice versa. But in this case, value of x is dependent on t and value of y is also dependent on t. But they might be interdependent, but we are not defining it that way. We are saying that x is a function of t and y is also a function of t. Here t is your parameter, which is determining what would be your value of x and y. And because of that only, since there is a different parameter which is defining or describing what your x or y value would be, it's called parametric equation. Is that a good starting point? At least relatable? Jenna, Vishal, Dev, Tanvi, all the kids here? Yep. Okay. And everybody looks very sad today. Except the kids on the screen whom I am not able to see, but here the kids in the classroom, they look sad. Is it because the school has started? Okay. I can only empathize with you guys. I've already gone through that trigger, so let's not worry about it. Okay. Hey Dhanushri. So Dhanushri, we are talking about parametric equation. So we are learning parametric equation today. And how we have started is, all the type of different equations that we have dealt with thus far, they are called rectangular equations because this represents the value of x and y in a rectangular plane, in a xy coordinate, the coordinate plane. They are called rectangular equation because the value of x is dependent on y or vice versa. Likewise in this equation also same situation. But when you look at parametric equations are the equations where the variables that you are dealing with, they have a common parameter on which they depend. And that's why they are called parametric equation. Is it sounding okay so far? So that's what we have covered so far, Dhanushri. So we have just defined, or we have just wrapped our head around understanding the difference between rectangular equation and parametric equation. And I'm not going to talk about rectangular equation because this will be a separate discussion whenever we talk about linear equation, quadratic equation, or any polynomial. That is when we'll talk about that. But today we'll focus primarily on parametric equation. Is that okay to begin with? Everybody with me? Okay. Now, so the key takeaway is when we are talking about a parametric equation, all the variables in the equation depend on a common parameter, and that parameter could be anything. I mean, here I am talking about t, it could be something else also. So let me give you guys a real life example to begin with. Let's say, let me not say anything. Now let's say, this is a building, okay? Probably has 10 floors or 20 floors, whatever. I'm not really worried about the number of floors this building has, but I'm only worried about the height of this building. Okay? Let's say this is 100 meter tall. Okay? A boy who is standing here, or maybe a girl, whoever loves throwing stones, is standing here and throws a stone like this. So let's say I'm that boy who's at the top of the building, throws the stone like this. Okay? So when he or she threw the stone comes and hits the ground. Okay? So let me now try relating this to a coordinate plane. Okay? So I will, just for the sake of visualizing this, I am saying this is my x coordinate and this is my y coordinate, and this is the height of the building. Okay? And let's say when I'm throwing the stone, I'm throwing the stone at a velocity of, let's say, 5 meter per 5 meter per second. So I'm throwing the stone in horizontal direction, 5 meter per second, and eventually because of the gravitational force, it moves downwards. So I'm throwing at, let's say, 5 meter per second speed. So if somebody says, now probably you might be thinking that if I'm throwing the stone at a velocity of 5 meter per second, standing here at the rooftop, after t seconds, how far along the x-axis or how far from the building the stone would fall? You will say, yeah, it's very easy. After 3 seconds, the horizontal distance will be 5 times t. Am I making sense so far? Am I being able to make sense so far? Vishal, Tanvi, Jenna, everybody? And stop me if I'm just talking to myself, okay? So, this is the building where a boy is standing. The building is 100 meter tall, and from the rooftop, the boy, the child, the teacher, whoever it is throwing the stone at a velocity of 5 meter per second horizontally, and due to the gravitational force, this moves along the x-axis and then also moves along vertically to come and hit the stone at surface. So you are saying that how far would the stone be after 3 seconds is a function of this. This is the right representation, right? So now what you are seeing is one of the variable, the x coordinate value, horizontal distance from the building, is a function of t. Now, this is my y-axis. Okay? Right now, it is at 100 meter height. At this point, is 100 meter height. After 3 seconds, what will be the height of the stone from the ground? And then you would have, again, I'm not trying to teach you guys physics here, but it is determined by s equal to ut plus half at square, half gt square, where g is acceleration, or here the gravitational acceleration, and t is the time. So and u is the initial speed. So this is yeah.
Wouldn't you have to add the boy's height as like part of the total height as well?
I'm assuming that is negligible compared to this one, just to minimize complexity in this.
Okay.
Maybe the boy is sitting or lying on the sort of yeah. Good example, bad example. Okay. No, I'm just saying, for the sake of simplicity, that's only a purpose. So this one tells me, this is the equation from physics. I'm not going to deliberate this further. I'm going to say that what will be the height of this along the y-axis would be this plus or minus, because this is moving downward and gravitational force is pulling it downwards, is half into g. G is gravitational acceleration, which is 10 meter per second into t square. So this, if you look at this equation, this becomes half into 10, that is 5t square. Forget about everything that I told you guys, yeah?
What was G again?
G is the gravitational acceleration. Gravitational acceleration.
Okay.
Meaning, if you have a stone here, you leave it. There is a gravitational force that pulls it towards it.
How do you calculate gravitational acceleration?
That's a fixed value. Like the value of pi is 22/7.
Yeah.
Gravitational acceleration by default in this Earth's atmosphere is 9.8 meter per second square.
9.8.
9.8 meter per second square.
Okay.
Whenever you guys get excited to talk about that, we can talk about that. I mean, but yeah, for now, forget about everything that I told. Just assume that here, this equation tells you that what will be the height of the vertical height of the stone when it is thrown horizontally, where it will, what will be the vertical distance is that it depends on this equation. Let's keep it that is the equation. This is a relationship given to you. Okay? Is that okay, guys? Or I'm getting you guys more confused? Huh? So everything that I told, just forget about it. You are given an equation saying that x, how far x will be from the building will be a function of this, because this is the velocity at which the stone is being thrown, and the vertical distance will be derived based on this equation. This is the equation given to you. Let's not mix it with the physics concepts and look at only mathematical formula. Is that okay? Is that okay, Jana, Vishal, Dave, everybody? Yeah, Dhanushri? Okay. See, this is the era of likes and subscribes, right? So I'm forcing you guys to like what I say. Okay. So here, what we are seeing is, this is a classic example of a parametric equation, where one of the variable x is dependent on t, and the other variable y is also dependent on t, and t is your parameter here. That determines what will be the value of x or y after the elapse of time. Yeah? So when I was talking about the parametric equation, right, what I was saying was that compared to a rectangular equation where x and y are dependent on each other, parametric equation is something where x and y, both the variables, are dependent on a third parameter. That's why it is called parametric equation. And this is just a practical example of that. Okay? And when we do a little more problems, then we will relate it. Now from this one, okay, there's one more concept that I want you guys to be aware of. Now let's say here in this equation, okay, why x and y depend on third thing? I mean, two things are more than enough for us to get our lives complicated. Why we are adding a third dimension to it, bringing t? Can we not relate x and y in there, using the same term? Let's see that. If I find out the value of t with respect to x and replace that here, we'll see that x and y are related again, correct? But before we go there, now here, when t is 0, meaning x has not moved, the start of the, before the stone is thrown, x is when x is, sorry, when, let's put a table here. Since everything is dependent on t, when for different value of x, t, let's see what is the value of x and y for every value of t. When t is 0, x is 0. When t is 0, y is 100. And how do you read it? When the stone is not thrown, horizontal distance from the building is 0, vertical distance from the base is the height of the building. Yeah.
Wait, does that mean like exponential equations are like this too? Or since they both depend on time?
I mean, that's how you connect the dots, right? I mean, we are right now looking at the basic concept. And then when you expand that further, when we'll talk about, let's say, even when we talk about quadratic equation, you will see a merit in this. Okay, and we'll probably come back to this. You're already seeing one quadratic equation here, right?
Yeah.
So here, we are just trying to plot the value of x and y against t, which is the parameter here. When t is 1, meaning after 1 second, what will be the horizontal distance from the, along the, from the building? 5 into 1, that will be 5 meters. What will be the distance from this one? This will become 100 minus 5 into 1 square, 95. When, at what time? So here what you are seeing is, you are here, after 1 second it's here, after 2 seconds it's here, after 3 seconds it's here, after 4 seconds it's here. So you have a starting point and you know the direction from this one. Okay. Now let's keep it here. Now from this you can find out at what time, after how many seconds will the stone hit the ground. How do you find it out? You will say, okay, fine, what time, after how many seconds will the stone hit the ground, meaning the y value will become 0. Or 5t square equals 100, or t square equal to 20, t equals square root of 20. Yeah? So after this many seconds, it will hit the ground. Are you guys with me? Everybody? Tanvi, Jina, Dev, Dhanushri? Okay. So from this what we found is, we can find out after how many seconds it will hit the ground, and at what position, how far from the building it will hit the ground. Once you find out the value of t, it takes t seconds to hit the ground, meaning in t seconds, let's say this turns out to be 4 4 16, 4.2 or 4.3 maybe. Here t comes 4.3 seconds. So if somebody says, how far from the building will that stone hit the ground? You'll put this t value here and you'll get that distance. So far this is okay, right? So the key takeaway here is, this is a parametric equation where t is, x is dependent on t, y is also dependent on t. From that we can find out, and we are seeing the direction here, how the stone is moving from this place to this place. Okay, so you should look at this in the layman's term. This is a curve. Everybody here, if you look at this as a curve, you know the direction of this trajectory. You know it starts from here, it's going this way, it's going clockwise or whatever it is. Yeah. Now, is everybody with me so far? Are we okay with the recap of whatever we have seen so far? Everybody? Jenna, have you gotten used to my speed better?
You can explain it like
Okay.
one more time.
Okay. So, first thing first, when you look at what is the basic difference between a rectangular equation and a parametric equation, that part is clear to everybody, right? Is that clear to you as well, Jenna?
Huh?
The basic difference between rectangular equation and parametric equation, that part is clear, I'm assuming, right?
Yeah.
And we are not learning any new concept, we are just trying to relate that with a practical example, okay? Where we are saying that a boy is standing on the roof of the building, or maybe a girl, or maybe a teacher, whoever it is, yeah? Standing on the roof of the building is 100 meter tall, and I'm saying that how far it will move, and the stone is thrown at a speed of 5 meters per second. So we are saying that, okay, when we, this is the equation that says how far it will move along the x-axis and how far it will move along the y-axis based on this equation. Okay, I'm not explaining you guys why this equation is valid. Okay, you know that, okay, I'm throwing at this speed, so after t seconds it will be 5 into t. That's the x value. And for this one, your gravitational force comes into play, and gravitational force applies something called gravitational acceleration. And based on that, this equation is there. You don't have to worry about how this equation came to existence for now. Think of this as an equation where it says x is based on this and y is based on this, and both have a same parameter t. Is that okay? So what I was saying was, so since x and y both are dependent on t, what we did was we plotted a table here saying, okay, since both are dependent on t, when t is 0, what is the value of x and y? When t is 1, what is the value of x and y? When t is 2, what is the value of x and y? And we said, okay, fine. After how many seconds will it hit the ground? So it says hit the ground, meaning when your y value becomes 0, stone travels from here to here, and that will follow this equation. So let's say after t seconds it hits the ground. That means the y distance, this distance becomes 0. So y becomes 0. So from this we found out what is the value of t, meaning after how many seconds will it hit the ground. That's what we tried deriving. I'll come to you. So Jana, is that part clear to you, beta?
Yes, sir.
Okay. So this helps us find out after how many seconds it will hit the ground, and once we know after how many seconds my horizontal movement is fixed, my velocity is fixed. So if this turns out to be 4.2 seconds, we can also find out how far it is from the building when it hits. Yeah.
How would like inverse equations work for this? Would it work the same or like?
When you say inverse equation, what do you mean by that?
Like, you know how like logarithm is the inverse of exponent, and like it's like their functions are also inverse. It's like that.
So I will not add that flavor, but I'll add a different flavor relating to the same concept. So just give me 5 more minutes. Let me conclude this. I'll come back to it. Okay. So, but is that understood so far? Jana, Dev, Dhanushri, Tanvi, Vishal, everybody. So only takeaway from this was that when you are looking at a parametric equation, you know that your starting point. When your my t is 0, my starting point is this. When my t is 1, meaning after 1 second, the stone has travelled along this path and is at this position. After 2 seconds, it has come all the way here, meaning this far along the x-axis, this far along the y-axis. After 3 seconds here, and after 4.2 or whatever second it comes out to be, it hits the ground. So here, in the parametric equation, you see that, you see a trajectory, the direction basically. It clearly depicts the direction for us. Okay? Now, the next thing that we want to do is that, okay, fine. The only takeaway here is when we are talking about a parametric equation, we know the direction, we know the starting point, we can follow the trajectory. But it is a tiring exercise. Why we are talking about x and y with respect to t? So far we have been dealing with x and y with respect to each other. Why we have to bring a third dimension to it? Can't we relate x and y with respect to each other? Yes, we can. Now look at this. Here, if I have these two equations, can I not write them with respect to each other, like x in terms of y, y in terms of x? Let's do that. Here, if you see, x equals 5t. That means t equals x by 5. Yep. If I plug this value of t into this equation, I will get the relationship between x and y. So y equals 100 minus 5t squared. 5t squared. T is nothing but x by 5. So y equals 100 minus 5 into x squared by 25. So it becomes y equals 100 minus x squared by 5. This is what we are used to, right? And if you know value of, again, so once you know this one, from this you can derive the value of x and plug it here. Yep. Yeah.
Wouldn't it be x by 5 squared and not x squared by 5?
X by 5?
It would be x by 5 squared because that's what t is, right?
Yeah. So you had a 5 here, right? 5 into x squared by 25.
I thought that was x squared by 5.
Yeah. So this is x squared by 25. X by 5 is our key value. So it became x squared by 25. I simplified that.
Okay.
Okay. So now I have equation terms x and y related to each other. Okay. Did I do anything cryptic so far? Dhanushri, Tanvi, Dev? No, nothing cryptic, right? So simply the parametric equation that we had, we got it tweaked to what we are used to. So instead of two equations in terms of x and y, we converge them into one equation. Now I have a quadratic equation. Yeah? I can use this quadratic equation. This is my quadratic equation, y equals 100 minus x squared by 5. This is my quadratic equation that got derived from this. So I have x and y related to each other this way. Yep. I can simply plot it on the coordinate plane. X, y value. Let's put some tables here. When x is 0, y is 100. When x is 5, then y is 5 square. 25 by 5 is 5, 95. When x is, let's say, 20, so this becomes 20 square is 400 by 5, 80, y is 20. And then you can say, okay, how about minus 5? And I have x equal to minus 5. You will put minus 5, it becomes 25, same thing. It will be 95. So when you plot it on a coordinate plane, you will see that this plots this, a parabola. Like any other quadratic equation, it plots a parabola for us. What are you seeing now? You have no boundary here. Okay? Here in this case, your t started from t equal to 0 and went all the way till maybe here, till y was 0, 4.3 or whatever. Greater than or equal to 0 and less than or equal to 4.3. You had a bound here. You had a limit here. Here there is no bound. Here in this case you had a direction. What you lost? You have parabola. Say that based on this equation, this satisfies this condition. It might plot, if you put t equal to minus 1, minus 2, minus 3, it might plot this parabola again. But it will be the same. But in case here you have direction, here you have lost the direction. You don't know what is the starting point. You are only knowing x and y relationship. Is it starting from here? Is it starting from here? Is it going from here to here? Or here to here? You don't know. So that's the main difference. It's again, if you guys relate that with vector and scalar situation, right? When you look at scalar quantity, you only know quantity. Speed and velocity, right? Speed has only 5 miles per hour. You don't know whether you're going north or you're going south, you're going east or west. Not west, west. Sorry. Similarly, when you talk about velocity, you are using a vector saying, okay, 10 miles per hour in this direction. Yeah? Same thing is coming into play here also. We are looking at a rectangular equation, you are just knowing the quantitative value, you are not knowing the direction. When you are looking at a parametric equation, you know the starting point, end point, and the direction of the trajectory. So, in layman's term, if you want to relate, a rectangular equation gives you only the values, the trajectory of the curve. It doesn't tell you the direction. Parametric equation gives you the direction and also tells you the starting point. Does it make sense? Who will give me one like or a thumb down? That's also fine. I need to know whether I'm making sense so far or not. Making sense? Okay. How about Vishal, Jenna? Jenna is thinking what to do. Okay, tell me, Beta, what's going in your mind right now? Okay. So, I have a very bad habit of thinking like a child, okay? Thinking like a child meaning, there's a movie in Hindi. I'm not sure you guys have ever watched that, and I don't think you'll watch it. It's one of the most flop movies, okay? In Hindi it says, Umar bachpan ki dil bachpan ka. In English it means, at the age of 55, you are like a child. So that's my situation as well. I'm not 55 yet, but I still have the what do you call, the feeling of a child. So I'm going back to that feeling. So here, when I look at these two things, okay, this is my parametric equation. This is the rectangular equation, and we have derived this equation from this one. Up to that much, it's clear, right? I mean, that's what you guys would have seen me doing, correct?
Yeah.
So, in this situation, when we were looking at this as parametric equation, when we were looking at how the stone is thrown and how it's moving, we saw that the stone starts from here, from the rooftop. When t is 0, the stone is lying here. After 1 second, it has moved this far. After 2 seconds, it has moved this far. After 5 seconds, it has moved this far. After this many seconds, it hits the ground. Okay. So essentially, when you are looking at this like a parametric equation, you are saying that, okay, I have a graph which is showing the trajectory of the movement of the stone, and you not only knowing the trajectory, you are also knowing the direction. So basically here you are saying after 1 second, this is where it is. What is the value of x and y? After 2 seconds, what is the value of x and y? After 5 seconds, what is the value of x and y? Here, the time thing is taken out of the equation. So you don't know. If somebody says, okay, you converted these two equations into this equation, which is a much more amiable one, and you plotted the graph, but where is the stone after 3 seconds? You don't know. Because the time thing is taken out of the equation. There is no time here. You don't know from where you are starting. Are you starting from here and going this way, or are you starting from here and going this way? So your direction and starting point both are lost. So basically when you converted this parametric equation into a rectangular equation, you will get the same absolute value, your graph will look the same, but then what you are missing is your starting point and the direction. Does it make sense now? Jana, did it make sense this time? Or anybody who thinks I did a better job this time? Yeah? Okay. So again, for you guys, okay? So anyways, whatever I'm doing, all that gymnastics I'm doing right now, that is getting recorded. So if there's some doubt that again comes to your mind, just look at the video one more time and see if you're able to kind of connect the dots. If it does not connect the dots, catch hold of me, okay? Let me know, sir, okay, I tried recollecting it, watched the video, still I'm confused. Can you explain one more time? And I have no shame in doing the same thing 5 times, okay? Alright? And I think when we try solving some problem, then you'll be able to relate it more. Yeah? Is that okay, everybody? Okay. So this is, so far we have understood what is a parametric equation, what is a rectangular equation, what is the difference between the two. Can I convert a parametric equation into a rectangular equation? Yes. Answer is yes. Now you will ask me, can I convert a rectangular equation into a parametric equation? Tell me what the answer would be. Yeah. Yes? Sure? I mean, again, it's a matter of debate. We are debating. We are just thinking, we are brainstorming. We are not fighting, but we are contemplating what is the right answer. I'm saying we just saw how do we convert a parametric equation into a rectangular equation. And in the course of this transition, we lost the direction and the starting point. Okay? Meaning, your rectangular equation doesn't give you the starting point or the direction either. So when you convert this guy from here to here, you would not know what is your starting point. If I tell you that x equal to 5y square minus 10, you can very easily plot a graph, and that's the easiest thing to do in life. X and y value, you keep on putting different value of y, find the corresponding value of x, and you say found those points, you plot them in the coordinate plane. You found it. But what is your starting point? Is x equal to 0 your starting point, or x equal to 25 is your starting point, or x equal to minus 30 is your starting point? You don't know. So converting a rectangular equation to a parametric equation is not possible because you don't have that information itself. Yeah? So it's like this, okay? Let me give you a very lame example here. Let's say I told you that, okay, this is the address of the classroom. Class starts at 7 p.m. Come to this address and join the class. And you took that information, you said, okay, class starts at 7 p.m. The address is this. I know this 49-year-old man teaches maths on Wednesdays at this address. And you don't have the time. You came to the class at 5 p.m. I had mentioned 7:15. You came to the class at 5 p.m. because you somehow in the whole in the process of digesting that information, you forgot about the starting point. So is the case with this guy. You know this is the path to follow. This is what this graph will plot. But you don't know whether you are starting from here, plotting this way and then going this way, or you are starting from here, completing the graph. And again, parabola has no limits, no bounds. So look at this rectangular equation. This has no bounds. Wherein, in case of your parametric equation, you are saying, okay, fine. Starting from here, my time varies from here to here. And that's how you have restricted the starting ending point. So that's the difference. So when you have to convert from here, from more information to less information, it's easy. You're just trimming the information. You have less information, you're trying to generate more information, you are assuming and adding to it. You have no scientific way to be convinced about whether your assumptions are correct or not. So this way to this way is easy peasy. This way to this way is more of a guesswork. Does it make sense to everybody? I have adopted the techniques of this era. So I'm not going to proceed unless I see a like coming from you guys or a thumb down coming from some of you. No, I'm just kidding. Tell me, is this clear so far? See, Tanvi is always trying to make sure that she gets the monkey off the back. First person to raise the thumbs up. Okay, but yeah, jokes apart, everybody clear, right? Okay. All right. So let's look at some problems that you guys will end up dealing with around these concepts. With all the blabbering I have done so far, let's see if that is good enough for us to solve some problems. So let me look at few problems I have noted down for you guys. So let's look at one problem. I don't want to scare you guys with a difficult problem in the first place. Let's start with an easy one. There is a parametric equation saying x equal to t by 4, y equal to t square. I mean, when I say parametric equation, basically you will have two equations, both relating to t.
It says x, right? The first one.
Yeah, x is t by 4. Courtesy my handwriting. X equal to t by 4, y equal to t square. These are the parametric equations we have. Okay, this is the question. The table below includes x and y values of the parametric equation at different values of the parameter t. Fill the missing values. And this is like a jump start, okay? So I'm just getting you guys geared up for something more tricky coming your way. -2, this is empty. This is 4, -1, -1 by 4, 1, 1, sorry, 0, 0, empty. Can you guys help me fill the blank rectangles here? These are the equations we have, and we have to fill in. There is a legitimate question coming from one of the city exam, yeah?
The first FT is
Negative?
-8.
8, okay, how about the second one?
That one is
This one is 0? Okay. How about kids on the screen? Can you guys see the board okay? So I want you guys to help me fill this one and these two boxes based on the equation we have. Let me do a better job with my writing. X equals t over 4 and y equals t square. Yep. I know this might sound like a very easy problem which you guys don't want to do, but give it a shot still. I mean, don't be surprised if you get a question like this in your ICT exam. Anybody? Dhanushri, Dev, Jenna, Vishal, Tanvi, anybody? What goes in the first box? Did I make everybody sleep? I'm sorry, beta?
It's a little bit hard to see the screen. There's like glare.
So x equals t over 4, okay? And y equals t squared. Can you guys see it better now?
Yes, sir. Is it t over 4 and then t squared?
Yes, t over 4 and t squared.
Okay, so for the first one, you can see, I think that says t is -2 on the side. So we could just plug that into the formula for x.
Okay, so this is a simple one, okay? So let me, so here, let me just fill it for you guys, okay? I'm not doing anything fancy here. This is the table that we have to fill. Since x and y both are dependent on t, we'll use the equation for filling it up. When t is -2, what is the value of x? When t is -2, so x will be equal to -2 over 4. That will be -1 over 2. Yeah.
I just solved for t and I multiplied by 4 on both sides and then I plugged in t.
But why you have to solve for
Oh,
t?
wait, did it wrong. That's
Yeah.
not that.
Yeah, that's why I was thinking, how did you get -8? Okay, so here it's -1 by 2. And for this box, when t is 0, x is 0. So when t is 0, obviously x is 0. 0 over 4 is 0, that this is fine. And this one, when t is 0, 0 square, that will be 0. So this was more like a jump start, okay? let's come to a little interesting problem. A little difficult one, okay? Relating to the same concept. Not the table this time, okay? This time you'll see the whole furniture, not only the table. And let me know if you guys can see it, okay? Consider these parametric equations. X equals cos of t over 2 and y equals sine of t over 2. It says which graph represents the parametric equation on the interval minus pi less than equal to t, minus pi less than equal to t, and that is t is greater than equal to minus pi and less than equal to plus pi. Okay, and then you have 4 graphs. Okay, graph A, one, this is minus 1, this is x and y. Okay, B is this way, this is 1, this is minus 1. C is 1 minus 1, this is x and this is y. And D is 1, 1. Okay. So you are given two parametric equations, x as a function of t. Here t is not time, t is angle in pi radian. I'm just telling you pi radian so that you can relate. Y equal to sine of t over 2. So these are two equations, parametric equations, both are function of t and t is the angle here. And you are given 4 options and you have been asked to find out which of the graph is representing this one in the range of t is less than equal to, t is greater than equal to minus pi and t is less than equal to pi. Now everybody must be scratching their head and don't do that much. There is a side effect of that. If you scratch too much, your hair quality will be like mine. Think about it. Okay, so again, we have 5 more minutes before the class gets over. I don't mind stretching it for 5 more minutes, but I don't think 10 minutes would be enough to solve it. But at least I want you guys to think about the approach. What would come to your mind and how would you solve it? You are given the range of t from pi to minus pi. First of all, if you are looking at angle, what is pi? Pi is here to here. What is negative pi when you are going in the clockwise direction? Same point. So it says whether you come from here to here or here to here, this is the angle that has been talked about. Yeah, basically straight angle.
Yeah.
Okay, and says less than equal to, less than equal to or greater than equal to, meaning both are covered. So you're talking about a straight angle. Okay, so what is x cos pi over 2? T is following the range of pi to minus pi. So this will become cos. First thing is simplify this, okay? Cos of t is pi to minus pi. Let's put pi here. Both are getting the same straight angle. I will say pi. Pi over 2, and this equals sine of, again t is pi over 2. So this is cos 90 degree and this is sine 90 degree. Now that should help you relate. Which graph are we talking about? So again, when you look at equation, right, ultimately equation is a contract between the variables. Based on this, we have found out, okay, what is the value of x? X is cos 90 degree. What is the value of y? Sin 90 degree. And if you guys relate to or remember what did we learn in the unit circle theorem, unit circle trigonometry, this is what we figured it out. I mean, but anyway, don't even worry about it. Look at cos, what, okay, let me give you guys some more clue. Cos 90 is 0 and sin 90 is 1. So these are peak values, meaning when you are looking at pi, when you look at minus pi, it will come to the same thing. So I'm saying, we are essentially talking about here to here. And this is 90 degrees. So basically you're talking about, sorry, this is your option. So you're talking about a y value up to 1. Y value up to 1 starts from 0, goes up to this. Yeah. So you're not talking about straight angle 180 degree. You're talking about 90 degree part only. 90 degree, if you relate that to the unit circle trigonometry that we have learned, you're essentially talking about only this part of it. You'll exclude this one, you'll exclude this one because this is the fourth quadrant. This is covering again semicircle. So this is 180 degree. Your range is only 90 degree. 90 degree when you're talking about, your y value changes from 0 to 1, and when you look at x value, it's 90 degree at the peak. X value changes from cos 90 is 0 and cos 0 is 1. This essentially covers the whole thing. And I know this might be sounding little daunting, but in a situation like this, while it's represented as a trigonometric function or as a regular xy function, right? See, it can be cos, instead of cos it might say, okay, y equal to t by 4. T is time here. It says, okay, it's in the form of the angle. So ultimately it's a variable for us. When you put an angle and find out the sine cos value, you get the absolute value of it. That's how you solve it. Okay? So don't get overwhelmed by looking at cos function or sine function. Ultimately it translates to some value. What you will do is, in this case also, let me just spend 2-3 minutes, okay? X equal to cos of pi over 2, y equals sine of pi over 2. What you will do is, you will recall the triangle, the table that we had prepared some time ago. 0, 30, 60, 90. 45 I skipped. Sine, cos. When angle is 0 degree. Sine 0 is 0, cos 0 is 1. When angle is 30 degree. Sine 30 degree is 1 by 2. Cos 30 is root 3 by 2. When sine 60 degree is, angle is 60 degree, root 3 by 2 and 1 by 2. 1, 0. Now, what is this one? Whatever you are seeing here, this is nothing but your y value and this is your x value. So, if you convert this into this table, here it is t, here it is x, here it is y, when 0, 30, 45, 60 and 90. X is this one. So 0, 0, this is x is cos. So this is, 1 root 3 by 2, 1 by 2 and 0. This is y is nothing but here, this one. So this is 0, 1 by 2, root 3 by 2, 1. And you will plot this one. So when you plot this, what you're seeing is for angle equal to 0, when this is angle is 0, x value is 1, y value is 0. This is your 1 point. When angle is 30 degree, x is root 3 by 2, and this is x is root 3 by 2, which will be close to 1, and y is 1 by 2 here. So this is the only one that satisfies this one. Okay? It will not cover, it will not go from 1 to, see, it will not go from 1 to 0 because your angle here is up to 90 degree. Within 90 degree, when you talk about 90 degree, your cos value varies from 1 to 0 and sin value varies from 0 to 1. So this is going to fall in the first quadrant because all your values are positive. So, I know I told a lot of things, but summary of that is, like any other parametric function, be it in the form of a trigonometric function, be it in the form of regular expression like t, x equal to sum of t or y equal to sum of t, you just substitute the different value. Here you are putting the value of the angle and using that to plot your graph, and then you will see that since you are given the range, the t has a range of pi to minus pi, that means pi by 2, t by 2 will have a range of 0 to this one. And based on that, you will see which one is satisfying this condition. Okay? I kind of rushed through it and I picked up this one, but when you look at both the situation, pi, t is pi and minus pi. Minus pi meaning you will look at this quadrant also. So this is why you might come back to this solution. So for now, the only takeaway is you have the equation, find out the parameter, based on that put the value of x and y, plot it, and then see which graph it matches to. Does it make sense or too much of nonsense? Jana, Vishal, Dev, Tanvi, Dhanashri, lot of confusion, right? And it's okay to have confusion, okay? Because today, let's consider we only learned for first 40 minutes, meaning we just understood what is a parametric function, what is a rectangular function, what is the correlation, what is the difference between the two. Parametric function gives you direction and starting point, rectangular function doesn't give you that. You can convert a parametric function to a rectangular function, vice versa is not true. And let's solve 5-6 problems in the next class relating to this one. Break our head with this. If that doesn't work, break the head of the teacher, we'll see. Alright? Yeah? So I'm just keeping the next class reserved for practicing the concept that we have learned today so that we get more comfortable with what we have learned. Is that okay? Tanvi, Vishal, Dev, Dhanushri and Jana. Is that okay, beta? Everybody? Jana is not wanting to say okay. She is not convinced, is it? Jana, I am waiting for you to say